Hi, it's Miss House. Let's review the negative exponent rules. If I have a base of x raised to the negative n, that means that this base, because it is currently in a numerator, will go to the denominator so that I can make the exponent positive. So x to the negative n is 1 over x to the positive n. If that x to the negative n is multiplied by some coefficient or some number c, the c is not affected by the negative n. The c remains in the numerator, and the base of x goes to the denominator with a positive exponent n. If the entire product cx is in parentheses raised to the negative n, the entire product goes to the denominator raised to the positive n, and of course the numerator is a 1. So in two cases the numerator will be a 1, but in the case where the coefficient is not affected by the negative exponent, that coefficient is your numerator. Now if your negative exponent is in the denominator, that base is going to go to the numerator, and that coefficient of 1 is here in the numerator and stays there. Okay, so this could be something like 3 over x to the negative 2. In that case, the 3 is unaffected, it stays in the numerator. The base of x goes to the numerator and gets a positive exponent 2. However, if there is a coefficient in the denominator, 1 over cx to the negative n, the coefficient is not affected by the negative exponent. It remains in the denominator. Oops, let me fix that. Because when I move this base to the numerator, it gets a positive exponent. So make sure you do that. The base is in the denominator with a negative exponent, moves to the numerator, becomes a positive exponent. And here I have 1 divided by a product, cx in parentheses, to the negative n. The entire product moves to the numerator and has an exponent of n, and that 1 coefficient is technically here in front. So there could be a number, so this could be something like 3 over 2x to the negative 3. So the 3 coefficient would remain. The entire base, 2x, would go to the numerator with a positive exponent 3. Then you would have to apply the other rule for product to a power, 2 to the third, x to the third, and then you could simplify from there. 3 times 8 x to the third is 24 x to the third. But the most important thing here is to take a look at what is actually moving from your denominator to the numerator or numerator to denominator. Only the thing that the negative exponent applies to, only that base, only the base the negative exponent applies to is going to move. All right, let's do some examples. Here we have in number 16 a negative 4 in parentheses raised to a negative 4. That means the entire base of negative 4 is going to the denominator, and it's getting a positive 4 exponent. There's an understood 1 here, which remains in your numerator. And then negative 4 to the 4th, you can enter in your calculator, but 4 times 4 times 4 times 4. 4 times 4 is 16. Times 4 times 4 is going to be 64 times 4, which is 256. So this will be 1 over 256. And notice I'm not doing the negative here because remember, a negative base raised to an even, right? So you got a negative base raised to an even exponent you can go ahead and assume that's going to be positive because it will be. Or you could do negative 4 times negative 4 times negative 4 times negative 4. Example 17. We have 4 times x to the negative 4. The 4 remains. The x to the 4th will be in the denominator. So x with a positive exponent 4 is in the denominator. Do not over apply your exponent. 1 over 6 to the negative 5. The 1's going to stay. The 6 is going to the numerator, becoming a positive exponent 5. And so here they've asked us to simplify, and there's no way you're going to know or memorize what 6 to the 5th is, so you're going to do 6, use your exponent key, to the 5th, and you're going to get that 7,776. And then times 1, so it's 7,776. Now we have a couple of options for number 19. We have negative 1/2 raised to the negative 3. So keeping in mind that the negative exponent means to take the reciprocal, what I can do is I can take the reciprocal and then raise it to the third, or raise it to the third and then reciprocal it. Okay? So one thing I probably don't want to do is to go 1 over negative 1/2 to the third. I mean, I can do it that way and do it on the calculator, but let's do it a different way. That's a lot easier. So we've got a negative, and that means reciprocal. Remember, flip the base, right? And we've got a 3 exponent. That means to cube it. That's the shortcut way to say exponent 3. So I'm going to do the reciprocal first, and then I'm going to cube it. So when I did the reciprocal, I removed the negative sign because that's what the negative sign tells me to do. And now I just do negative 2 to the third. That's going to be an odd number of negative bases, so I'm going to get a negative answer. The answer to this is negative 8. Number 20. I'm going to do the reciprocal first, 6/5. Then I'm going to raise it to the second power, 6 to the second over 5 to the second is 36 over 25. 36/25 is my final answer. In number 21, I want to be careful. I want to remember that I don't put these in a single denominator because of the plus sign. This is going to be 1 over 6 to the 1, which I don't have to write the exponent 1, plus 1 over 7. I can use my fraction key to answer this, or I can get a common denominator. Now 6 and 7 will both go into 42 because 6 times 7 is 42. So to make both denominators of 42, multiply the top and bottom of this one by 7, the top and bottom of this one by 6, and I get 7 over 42 plus 6 over 42, and the answer is 13 over 42. Now, many of these problems that are all numerical without variables, you might be able to do on your calculator, but there will be a number of problems that you cannot do on your calculator, so it's important that you do even these manually using the properties and not just by plugging everything into the calculator. So this concludes this video, and I'll do some more mixed practice and something called scientific notation in the next video.